Hi everyone, this is Miss Segovia and I'm going to work you through the practice problems for Projectile Motion 1. Number 1, at the top of a 245 meter tall building, a sphere is launched with a horizontal initial velocity of 20 meters per second. Assume air resistance is negligible. How many seconds after the launch does the sphere reach the ground? So let's go ahead here and, as always, start with a little picture. Always helps to have a picture on these physics drawings just to kind of illustrate what's actually happening. So here we have a 245 meter tall building, and we are launching a sphere off the top, and they actually tell us here that our initial velocity, horizontal velocity, is 20 meters per second. So this kind of gives us a picture of what's going on. Here are our givens. They gave us the height, so y equals 245 meters. They gave us our initial horizontal velocity, so that's Vx equals 20 meters per second. And we also know that gravity is 10 meters per second squared. So our unknown for this particular equation is time. So what formula can we use to solve that? Well, since it's falling down off the building, doesn't matter if it falls straight down or at an angle, we can use our free fall velocity problem. So that y equals 1/2 gt squared. So let's go ahead and sub and solve on that one. Our y again was 245 meters. We've got 1/2 times gravity, which was 10 meters per second squared, t squared. So we're going to have 245 meters equals, I was going to work that out. 1/2 times 10 is 5 meters per second squared, t squared. So let's move the 5 over underneath our 245. So 245 divided by 5 is 49. Oh, you can already see what this one's going to be. 49 seconds squared equals t squared. So that means square root of 49 is 7. 7 seconds is our time that this sphere takes to fall off our building. So let's go ahead and go on to part B then. What horizontal distance has the sphere traveled before striking the ground? We're going to use our same givens from the previous slide. I'm not going to rewrite them here, but our unknown this time is x. And so the equation we can use for this one is one that we got the other day off our warm-up sheet, and that is x equals velocity times time. So when we plug those numbers in, our horizontal velocity was 20 meters per second. Our time, we just learned a few minutes ago, was 7 seconds. And so simply multiply those two together, and x equals 140, cancel out our seconds, meters. So that projectile will hit the ground 140 meters away from the tower. Question 2. At the top of a 45-meter tower, 2 baseballs are released from rest. One is dropped and the other is thrown horizontally with an initial speed v. If the baseballs land 30 meters apart, then what is the initial speed? So let's go ahead and draw our picture for that one. We've got our tall tower here, which is 45 meters high, so from base to top. We have our little person up here. One is dropping a baseball down, and in the other arm, because he's very talented, he is throwing the other baseball out to the side. So one's got an initial drop, the other one's got a vertical or a horizontal velocity to it. So we've got 30-meter difference between the two. So let's go ahead and calculate what that horizontal velocity would be. Our givens for this equation: we have our height of our tower, y equals 45 meters. We have our distance that the two land apart, and that is 30 meters. And our favorite force, gravity, fallen at 10 meters per second squared. Our unknown in this equation is our velocity. So what can we do? Well, we can use our equation x equals velocity times time. But we got a little problem because we don't know what the time is. So first we've got to figure out time, and we've got another handy equation. I'm just going to move up over here that we can use for that, which is our free fall. Y equals 1/2 gt squared. Remember, they're going to fall at the same rate and hit the ground at the same time, so we can calculate this and then apply our time back to our distance formula. So our y on this case is 45 meters. We have 1/2 times 10 meters per second squared times t squared. So we're going to end up with 45 meters equals 5 meters per second squared t squared. 45 divided by 5 is 9. And we'll have seconds squared because our meters will cancel, is t squared. And so we end up with 3 seconds for our time. So now we can take our 3 seconds here and we can apply them over to this equation here. So our distance that they land apart is 30 meters. We're solving for velocity. We have our time is 3 seconds. Looks like 35. It's 3 seconds. And then we can just divide out. So 30 divided by 3 is 10. And we got our labels, our meters per second equals our velocity. So that ball that was thrown at 10 meters per second. In a tall building, a certain window is 80 meters above the ground. A tennis ball is catapulted horizontally out of the window with a horizontal initial velocity of 8 meters per second. How far from the base of the building will the ball land? So this is actually kind of similar to our last question, just we're only looking at one moving this time. So let's go ahead and draw our picture first. We have a 80-meter tall building. Our tennis ball, let's catapult it out of a window. Let's pretend the window's on the roof. All right. With a horizontal initial velocity of 8 meters per second. And we want to know how far from the base will it land. So that is our x value. So our givens for this particular one, we have our height, y equals 80 meters. We have our horizontal velocity, which is 8 meters per second, and our good old friend gravity at 10 meters per second squared. Our unknown for this equation is x. So again, to solve this one, we would use the same one we used before. X equals our velocity times time, but again, we don't have the time. So we've got to go find it. So let's go ahead and use our handy-dandy free fall equation. Y equals 1/2 gt squared. We have our height of 80 meters times 1/2 10 meters per second squared t squared. We're going to end up with 80 meters equals 5 meters per second squared t squared. And 80 divided by 5, plug that into your calculator, you should find it 16. Second squared equals t squared. So once we take the square root, we get 4 seconds equals time. So now we get to come back over here and put time into time. We've got x equals, our horizontal velocity again was 8 meters per second. Our time is 4 seconds, and so 8 times 4 is 32. And our seconds will cancel out, so we get meters. So your final answer there is 32 meters. Our fourth and final question. A rock is thrown with a horizontal speed of 30 meters per second forward from a bridge. The rock reaches the water below 2 seconds later. Let up and forward be considered positive. What is the horizontal component of the rock's velocity when it reaches the water? So if we draw a picture on this one, we have our little bridge, we have our water below, we throw the rock, and it's going to hit the ground in 2 seconds, and it was thrown at a horizontal speed of 30 meters per second. Well, this is kind of similar to when we do our whole arc thing. If you guys remember that, when we looked at our horizontal velocities going through there, when we drew all those triangles, we saw that the horizontal component remained constant throughout the path of the trajectory. And so even though we're starting at the top of our trajectory if we're on a bridge and throwing it down, the horizontal component's going to remain the same. So in this one, I love it. No math necessary. Our horizontal component is just 30 meters per second because that horizontal velocity is constant and we don't have to calculate it since they gave it to us in the question. In 4B, we got to do some math, unfortunately. What is the vertical component of the rock's velocity when it reaches the water? So let's go ahead and list out our givens on this particular one. We have our horizontal velocity is the 30 meters per second. Our time is 2 seconds. And our gravity is 10 meters per second. So to find our vertical component, that was the equation that we gave you guys the other day. The equation that we use for here is our vertical component is negative GT. And we're using negative this time because it is falling down. So we have to show that it is a downward motion. So Vy is going to equal negative 10 meters per second squared times our time, which is 2 seconds. So 10 times 2, our vertical velocity is negative 20 meters per second because our second squared cancels and seconds cancel. So that one was actually pretty simple. And then we have our final one, part C. What is the speed of the rock when it reaches the water? Well, if you haven't guessed by yet, since they gave us our horizontal component, which was 30 meters per second, and they gave us the vertical component, or rather we calculated for it, which is negative 20 meters per second, vertical, horizontal, and they want to know the hypotenuse. We're looking at a triangle again, folks. So we've got our vertical velocity heading down, negative 20 meters per second, horizontal 30 meters per second, and we want to know what is our actual velocity. So Pythagorean theorem, here we come. We get v squared equals vy squared plus vx squared, and we just plug our numbers in here. So we're going to have our negative 20 squared plus our 30 squared, and it's meters per second. I'm just getting a little sloppy here. Sorry. We'll put the labels back in at the end. We have negative 20 squared actually ends up being positive 400. And positive 30 squared ends up being 900. So v squared is 400 plus 900. That is 1300. And it ends up being meters squared over seconds squared. And so once we take the square root of 1300, our velocity is 36.1 meters per second. And that is how fast that rock is going when it hits the water. Well, that concludes this worksheet for projectile motion. I hope you had fun. Let us know if you have any questions. Thank you.